So now that we've walked through the code for the Search with Parallel Spliterator case study, let's take a step back and talk about the pros and cons of what we've ended up with as our solution here. So we'll start with the good stuff. So one of the nice things about this example is it shows how you can write a parallel spliterator that will transparently improve program performance. Transparently, I should put transparently in quotes because we had to do the implementation to make it do this. But the nice part is once we've done an implementation, we get this nice speed up. And as you can see, the parallel spliterator implementation does indeed execute faster for this particular configuration than the version that used the parallel streams approach that didn't do searching the input string in parallel. And of course, all this stuff is way faster than sequential. So we can, in fact, improve performance. This was just another run. This was run on my Windows laptop a couple years ago. This is run on my Mac laptop a couple years ago. And I should actually rerun this stuff because now I have a laptop with a lot more cores. This was a quad-core MacBook. Now I have a 10-core MacBook. So it'll be interesting to see whether the performance changes at all. But you can see that the spliterator version that was more aggressive did, in fact, work better. Why does that occur? It occurs because the granularity of parallelism is finer. There's more things to do at the same time. And therefore, we're able to do a better job of leveraging the available cores. This example also shows, if you play your cards right, you can make these changes with relatively limited impact on the bulk of the program. So switching from the sequential version to the parallel version of this whole thing was just a matter of passing in true versus false as this fourth Boolean parameter parallel to the search for phrase method. So not a whole lot of changes, very much like we talked about before where we went from sequential streams to parallel streams just by doing sequential versus parallel streams. Again, very simple thing to do. Of course, and this was what we'll talk about in more detail in a second when we talk about the cons of this whole thing, it was not easy to implement the phrase match spliterator. That took a fair amount of time. The good news is once it was done, it was very cool. But that part didn't come for free quite as much as going from stream to parallel stream did when we went from sequential to parallel streams. So that's a wonderful segue into the downsides. As I always like to say, it's not all unicorns and rainbows. There's some tricky parts to this. And the key point is that it was a heck of a lot harder to program the phrase match spliterator for parallel programming than for sequential programming. And that's because we had to implement all these other methods. We had to implement try split using compute start pause, try to update split pause, and split input. Split input was easy. Compute start pause was easy. Try to update split pause was a lot more complicated because we had to account for the fact that we didn't want the phrase to straddle a split in the input string. And that took a bit of thinking. So point is you have to split very carefully. Something else that I will note is when I first wrote this stuff, I didn't write unit tests. So as a consequence, it didn't actually work correctly. And it wasn't clear it wasn't working correctly. And so I had a colleague who helped me find the problem. And so together, we were able to fix the problem. And I also added some unit tests so that henceforth, if I ever make any changes to the implementation, I can test to make sure that the results are what I would expect. So that's just a good pitch for testing. Testing isn't perfect, but it's better than nothing. And hopefully you see that with the programming assignments that we give out here. The tests don't catch everything, but they catch enough that you can fix most of the problems before you submit your code. Writing the parallel spliterator actually took longer than writing the rest of the program. So all the other program parts were really simple and very straightforward. Writing the parallel spliterator took a lot longer. There was more opportunities for mistakes because it's just very, very subtle logic. So that's the end of the evaluation of the Search with Parallel Spliterator case study. At this point, we are effectively done with our coverage of parallel streams. And the rest of the course is going to cover a whole bunch of other really cool asynchronous and reactive approaches to doing concurrent and parallel programming.